Hello everyone, it is really wonderful to be on this platform and thank you GSCI to give us the opportunity to conduct tech workshop on the very latest technology, that is quantum. So now we will go through with the agenda. So before agenda, I will introduce myself. I am a Richa. I am a lead AC at Society General and I have worked with the multiple technology like blockchain, quantum and also big data. So Anamika, let's introduce yourself and then we will go with the further agenda.
Yeah. Hello everyone. Welcome to today's session. My name is Anamika. I'm working as a senior software developer. My expertise involves building applications on top of automation platforms like Oracle Siloqua, Adobe's Marketo, and many such platforms. Today our topic is how a quantum computer is going to be a game changer. Let's deep dive into it. I'll let my co-presenter continue.
Okay, so today we are going to talk about the quantum, why quantum we are using, what is the core concept, progress highlights, and where it is a benefited for the society. And also we will see on the last of the session coding demo and we'll go through with the some hands-on. So let's start with the some interesting quiz. So to make session interactive, we have found there is some great scientists like Albert Einstein and also Niels Bohr, Richard and also Max Planck. So you need to give the answer on the chat box window for these questions. Like this is the very famous equation equal to mc square. Second one is the who has given the theory of the hydrogen atom and who has discovered the quantum of action. So participants can give their answer on the chat window and we will reveal the answer on the last of the session. So you need to give answer based on this scientist and then we will go through with the main agenda. So now, what is the problem statement for the quantum technology? So quantum technology is not replacing another technology like classical computing and another thing, but it is giving the extra advantage to solve the real world problem. Like we have a finance problem, a health problem, defense problem, and everywhere if we will go through with the normal classical computing, we will see it is taking the huge amount of time and we are not able to solve the problem quickly. But once quantum computing will be there in a market, so we will be able to solve the drug discovery problem, security problem quickly. And if I will talk about the exponential scaling, so nowadays common problem is the growing data. Now, already big data is there, so why we need a quantum computing? So if I will talk about the quantum computing, once data will be there suddenly after the 10,000 years we will not able to see what is the going in the past and what is in the future, but quantum computing will give the exact result using the some concept of the source algorithm and another algorithm quickly. So if you will see the some example like KYC, risk profiling, fraud detection and another like DNA sequencing is in research by the different companies. So now we are saying okay, there is a multiple problems, but why it is used by the companies? So quantum computing is not a new technology. It is based on the very old concept of physics, that is quantum physics, and also it is using the laws of the quantum physics, that is like superposition, entanglement, interference, qubits. So I will talk about the superpositions. So let's take one example, flipping the coin. So if we flip the coin, there is a head and tail, but we don't know in the final stage like how it is flipping. In final stage, we will got to know like, okay, this is the head and tail. So similar behave like superposition works. Actual state will not decided till the end. Same way quantum algorithm will work. Like there we will not know like okay, this is the first step and there is a second step. In the last step, suppose any game is going on, so in last step we will got to know who is the final winner. So similar like entanglement. Entanglement means like entangled particle if it is in a very long distance, but property and behavior of the entanglement feature is already in connected. So that time we can see like, okay, we are using some example like teleportation. Like if where information is going on, and that time we will not able to see, okay, what information is sent by the machines and etc. But in last we will able to see, okay, behavior of that properties is similar like interference. So interference is majorly used for the superconductor. So superconductor is nothing superconductor that whatever we are going to use for the quantum computer. So there is also research is going for the interference, like how we can implement in effectively manner. Now if I will talk about the qubits. So qubits is like in classical computing we have a bits that is only represent the 0 and 1 state. But in qubit it is represented by not only 0 and 1, it can be on the any state like 0 1 1 1 1 2. But it is a technical thing, but in real world how it will behave. Like suppose if we are saying, okay, superposition is there. Superposition means we are flipping the coin. We don't know head and tail, right? As I told earlier. So similar like in qubit is a state that measures the superpositions. So there we will see, okay, in head and tail can be in similar position also, either horizontal, either vertical. So it is the major concept that is used for the quantum algorithm and another quantum mechanics features. So let's continue with the next slide.
Well, that was a very well explained the where all this quantum computation is going to be used, different areas, and what are the basic concepts. Before we get into more details, it's important to understand how classical computers is different than the quantum computer. There are different criterias which can be used to measure the differences between the classical computer and the quantum computer. The very first criteria is unit. Well, as we all know, the classical computer accepts bits, the binary bits, as an input. However, the quantum computer accepts qubits, which is known as quantum bits, and this is nothing but the bits, but in the superposition of zeros and ones. The second is the operations. On the bits in the classical computer, the relational and algorithmic operations are being performed. However, in the quantums, there is a unitary operations that are getting performed. Now, coming to the directions. When it comes to the classical computer, the zeros and the ones, they are getting mapped into a truth table, and on top of it, the logical and arithmetic operations are being performed. However, in case of quantum computers, those are getting presented in terms of a unitary matrix, and then the unitary operations are getting performed on the qubits. The other is the directions which description which involves the classical computers uses the reversible gate. Sorry, the quantum computers use reversible gates. However, the classical computer, as we know, it uses the most forward gates. Now, moving on. Now, this is the architecture. So basically, for any system that are getting built, the basic component is an architecture. In the computer architecture is basically the combination of different parts, how many subsystems are there, how they are connected to each other, and how they communicate to each other to perform certain tasks. Now, with the quantum computer, currently there is no concrete quantum computers. It's like a hybrid system, which includes both the classical computer as well as the quantum computers. Now, when I say classical computers, so currently the structure is like the input is going to be accepted from the classical computers, but a part of for a large program that is going to be performed by quantum computers. And as we know, the quantum computers will doesn't have a concrete output. It will always have the outputs in a different states, and those states are coming from the quantum machine state that is known as stub to a quantum computer. The other way to look at this overall system is like how we have in our day-to-day system. If we have a GPU, which is graphical processing unit, that works as a co-processor. So similarly, quantum computer is going to be a co-processor to the classical computer, which will perform certain tasks. Now, within a computer, there are certain parts which is important, like the memory. So in case of quantum computers, the memories is known as registers and quantum registers, so where all the quantum data is going to reside and the operation is going to be get performed. Now the next part comes, and unlike in the classical computers, we have the registers where the smaller data are getting stored, and the RAM where the large data gets stored. In case of quantum computers, we don't have such concept here. It's all the registers where the quantum data is getting stored and they are being processed. The second part comes is the performance. When we talk about whenever we are talking about the quantum computers, the one major component which we are always going to cover is the performance. As the classical computers, it takes for a classical computer to execute like certain days, whereas the quantum computer is going to perform in a very rapid manner. It will be exponentially faster than the classical computers. So this is the overall architecture that we are covering. There are many minor and major components of a quantum computer which is there, and I'm not covering that well, but yeah, this is how we have currently the hybrid architecture. Now let's move forward. So we have this Schrodinger's cat experiment. To understand, basically this experiment is to basically understand the nature of quantum theory. So Austrian physicist Erwin Schrödinger is one of the co-founders of quantum theory. However, he is widely known for this Schrodinger's cat experiment. So Schrodinger's cat experiment is basically a thought experiment which helps to explain how strange and what could be the behavior of a quantum theory. And the theory says that an object can be in a different states at the same time. Now, in this experiment, a cat is placed into a sealed box, and a random quantum event which is releasing a poisonous acid which has chances of killing this cat is 50-50%. Now, according to the quantum theory, it says until an object is observed and measured, an object can be in all the possible states at the same time, which is like a multiple with the multiple possibilities, and this state is known as superposition that we had covered in the concepts of quantum theory computer. Now we can see that the cat here is in a superposition state. It's dead and alive at the same time. So basically, quantum mechanics is basically gets applied to the very very small objects like atoms, subatoms, and photons. However, in our day-to-day life, we doesn't come across these type of objects. So that's where the idea behind this experiment was to explain the behavior of quantum theory in a very layman language. And this theory also helps us when we are trying to solve big complex problems using the quantum computations. So this is what the Schrodinger's cat experiment involves. Now let's move forward and see the progress of the quantum computers. Well, this quantum mechanics, basically the quantum theory, that has been launched in some 20th century. However, the word quantum computing came into the picture later in the 80s, where the Paul Benioff, the physicist, he proposed a machine which can solve the complex problems using the principles of quantum mechanics. Later on, in the same year, the scientist Richard Feynman, he explained that most of the quantum simulations cannot be run on the classical computers. That's where he proposed the how he proposed the idea of how the quantum computers will look like. However, the research and development continued, and it took about almost 10 years to validate these theories and come up with the algorithms which can run on these type of computers. 90s, during the 90s, that year was a remarkable year in terms of the in the progress that we made in the field of quantums, as the first the Peter's source algorithm came into the existence. So basically, the scientist Peter was able to factorize a very large number in an exponential lesser time, which can basically break all the cryptographic system that we have today. Now, there was another algorithm, the Grover's algorithm came, that was to search the data into a unsorted database. So currently we have this challenge when we have a very huge large database and we want to search in the unsorted database. It's a challenge. So that's the algorithm was present back then. Also, the first 2 qubit quantum computer was also built in the same decade. Later on, the research and the development continued. Every 2 years, the challenge was to basically keep increasing the qubits. The qubits is the bigger the qubits we have, the bigger complex problems can be solved using the classical computation. However, during this phase of the progression that we made, 2017 turned out to be another milestone, as companies like IBM and D-Wave, they had implemented first working quantum computers where the source algorithm was executed also smaller for the smaller numbers. Still, we don't have such systems, the full-fledged commercial quantum computers. However, different organizations are conducting and doing the development to basically build different components that are going to be contribute to get the first working quantum computer. In 2020, we have seen that now we are in a path to basically build the quantum computers. There are computers getting built system that are going to basically measure the performance of quantum computers, how they are working. And also, with the existing system, we are trying to run the simulations to basically understand how what are the limitations and what are still the challenges that are exist with the quantum computers that needs to be taken care of. So this is the overall progress that we have seen. There is a long way to go. However, the progress that we have made is already remarkable, and it is going to change the industry almost and in fact it's changing in a way. Let's move ahead with that. Now, we covered the part where we have seen the progression that we have made in the field of quantum computing. Now, in a way, the quantum computers are already transforming the industry, as we have seen that the quantum computations has a potential to solve the very large complex problems that cannot be solved using the classical computers. This can be a breakthrough products in the area of chemistry, biology, artificial intelligence, machine learning, and many such areas. One way to understand that there are certain areas and certain problems that could only be solved using the classical computations, as we are expecting the faster computations and a large data to be processed at the same time. However, the actual quantum computers is still in a fancy. However, the different companies are in a process to make this reality, as they are in a race to build a high performing complex computers to solve the next generation problems. Now, there are some remarkable areas which needs to be looked into to understand how this is going to be applied and how this is already changing and going to change the industry, which involves that the very basic problem of computers is identifying the shortest path. when it comes to deploy, let's say car from one place to other place, or also identifying what could be the best route to reach out to a certain location. These type of problems is definitely going to be solved in a best possible way with the quantum computation. The other area is the pharmaceutical. Currently we saw that when it comes to you know to implement a drug from a basic level, it takes years to do all the simulations and find different combinations. However, with the quantum computations, the power of processing, the parallel processing, and it is going to be dramatically change the area, because the simulation is going to be much faster with the better results. And there are many such areas, like the AI, the self-driving car that we are talking about, which will help also to cover, with a larger data to be read and process in a very fast manner. And there are companies, not just that. So this transformation is taking already place, and different organizations are giving their inputs in terms of they are building different parts of the parts of the quantum computers. When it comes they are the company like Honeywell, they are focusing out to building a trapped ion quantum computers. One such example I would like to mention is, recently Mercedes-Benz has been, conducting the research to identify the different, all the possible of the batteries that can be used, to the next electric cars. So they are one such example. However, there are many such transformations are going on already. Now let's get, so these are the impacts that we are seeing with the quantum theory. Let's move ahead and to continue to understand the importance in different areas.
Yeah, as we have seen, there is a lot of progress and transformation happens in the industry. But what industry is doing? So industry is working on the certain types of algorithms and also gates. Like in classical, we have a certain gates that we are applying for calculation and computation. Similar, like in quantum, we have a famous algorithms like source algorithm, Grover's algorithm, QEA algorithm. So what source algorithm is doing? So as we know, in classical computing, we have a RSA encryption that is used for the credit card transaction to secure the servers. But what source algorithm is doing, it is able to crack the RSA encryption. So how it is doing? So if we will talk about the RSA encryption, in RSA encryption is a public key encryption. So here we need to crack the RSA. We need to do the prime factor of the large complex number. But in classical computing, if we want to do for the 232 decimal digit, it will take approx 1000 of the years. But in quantum computing, using the source algorithm, it is the fraction of the second. So only RSA is just safe in classical computing because of the time, because no one will see the future and we will not able to crack. So in that case, we need to do either in classical computing more secure, or we need to see the what we can achieve using the source algorithm for the encryption. Apart from that, it is solving the period finding problem, another cryptography, etc. If I will talk about the Grover's algorithm. So Grover's algorithm is nothing. It is just used for the searching the database. So if it is a simple, why we are talking here? So Grover's algorithm, what it will do, suppose we have a huge data set and we want to search only one key. So suppose there is a 10 records, we will be able to see. But suppose we have that much record, we will not able to count itself, and we need to search one data. How much time it will take? Assume it will take so many years. But using the quantum algorithm like Grover's, it will speed up the unstructured database and it will return true for the single result using some mathematical calculations, and that time we will be able to see the results quickly. So both like source algorithm is helpful for the cryptography and different problem, and also period finding problem. There like data optimization, if we will talk, there also source algorithm we can use, and it is not used, it is already applied by the many industry, and they are doing research for the prime factorization, data optimization, and etc. Now we will talk about the use case. So as I told, like that algorithm is used for the multiple use cases. So for multiple use cases, if we will talk about, suppose there is a financial forecasting. So financial forecasting is also done by the classical computing. So why we need quantum? So suppose there is a huge population, and based on that we need to see, okay, in future what is the forecast for the financial thing. So here what quantum algorithm will do, it is storing the population data in qubits. It is not like single digit. It will store the data on the multiple state. So here it works on the probability of the populations, and based on the certain algorithms like UA and another based values, it will apply for the quantum gates like Hadward gates, C0 gates, and then after calculating based on the each step, last we will be able to get the results. It could be exact result, it could be like, okay, 90% result, but it will be better than the classical. So next use case if I will talk about, that is massage cryptography. Massage cryptography is nowadays more famous, and it is already implemented by multiple industry. So as I told, in RSA scheme, we will be able to encrypt and decrypt data easily using the quantum computing. So there is a different approach like quantum key distribution. So how it will work? It is working based on the polarization state. So suppose there is a two entity, and suppose A is sending some data with the qubits with a random choice, and in another side, like suppose there is a B, they will be able to capture that data without knowing what is the exact key sent. But in middle, if any eavesdropper will come, they will not able to hack easily. So that time, so what is the benefit if another person is not able to see exact data? So there is a not exact key, but there is a certain idea will sent by the user A to user B. Like suppose if it is hacked by the any hacker, so that time another person will be able to see, okay, its state is changed. So here everything's work on based on the state. So going on more detail on the quantum cryptography. So cryptography, as in classical computing, if we will say, process of encrypting the data using the principle of normal classical computing is a cryptography. But here, if we are not using the mathematical calculation, only we are using the features of quantum mechanics like superpositions, qubits, and entanglement, and then we want to encrypt the data, that is referred as a quantum cryptography. So as you are able to see in a screen, we have a Alice and Bob's in two stations, and they are sending using the filters like Alice and Bob is in two stations, and they are sending the data through the filters randomly. So here if you will see, there is a 4 possible state. It is not only 0 and 1. It can be any polarized state, normal, horizontal, vertical. So if they are sending any data to Bob, a polarization state can be changed. So once photon will travel, suppose there is a photon, and in Bob's side, whatever filter is used by the Alice, Bob will use the same filter. If they will use the different filter, they will not able to see the exact data. So that will only come. So Alice, whatever filter they are using, same filter Bob's need to use. If they will use, suppose eavesdropper came and they don't know the exact filter, they will not able to hack. And if they are using different also, that time polarization state will change. And that time also it is not easy to crack the quantum data. Now once receiver receives the data, what it will do, it will do the beam splitter, and using the beam splitter, it will calculate the each sequence of the photon that were sent. Then normal, the sender compares the whole the information, and in last it will see the okay, whatever polarized state he has sent, it is matching with that key. So it is like the very big concept, but we need to see how we can implement. So using the during our hands-on, we will use some qubits and qgate algorithm, and we will see how we can start the coding on using the qiskit. Proceeding with further, like these are the very concept that is famous for the quantum computing calculations. But for that, what we need, so attendee need to install the Python. With Python, they need to install the qiskit, and after that, if anyone is not able to install the qiskit, we have an alternative approach, like we can do the technical kata, and as well as we can use the online qiskit online tool. So it will be helpful for the any attendee. So further, if I will go with the some reference, like we have explored and researched using these links. Many things is available on the Google, but it will be very helpful link that attendee can go on. Like till now we have discussed whatever we want to do on the presentation, but yeah, in coding demo we will explore more, and further if we need to see like how we can do the hands-on, for that another requirement we will share on the lives. So thank you so much for presentation, and Anamika, you want to add anything?
Yeah, it was, it was overall a very well, explained, and it was a great to discuss and to basically highlight what are the potentials of a quantum computing can be, and it's how it is going to transform our industry with different algorithms and different capability it has. So yeah, with that we'll just end the session. Thank you everyone.